So we just talked about physical and chemical properties. There are also physical and chemical changes. So in a physical change, and these things are related, in a physical change, the matter changes its appearance, but not its composition. So when something melts, like when ice melts, it's going to look different, isn't it? And some of its properties will be a little different. But the components of it, the particles, are unchanged. So water melting is a physical change. The fact that water melts at 0 degrees Celsius is a physical property of water. Okay, so physical property and physical change are very closely related, but there's a subtle difference. In a chemical change, the matter does change its composition. So copper. If copper exposed to the air, like on the Statue of Liberty is covered in copper, what color is copper? It is copper colored, like a shiny new penny, right? Statue of Liberty, does that look like a shiny new penny? No, because the copper has reacted with the air and formed a copper oxide. Now, is it necessarily a bad thing? No. You know, it's a patina, right? It's fancy. It's a patina. It's got that lovely greenish color. But the surface of it is no longer pure copper. Okay? It has undergone a chemical change. The chemical property of copper is that it reacts with air in that way. The chemical change is when it does it. Very, very subtle difference there. So when matter undergoes a chemical change, we say it undergoes a chemical reaction. So chemical change and chemical reaction mean exactly the same thing. So in a chemical reaction, which of course, you know, this being chemistry class, we're going to be talking about chemical reactions. In a chemical reaction, you have the things that you start with and the things that you end up with. There's a change, right? So you started with one thing, you end up with something else. So the things that you start with are called reactants, and the things that are produced are called products. So the reactants react to produce the products. Okay? So some of these words we have are words that maybe we use in the English language. No. Back up. We use them in real life, just, you know, regular life. And then it's the same word in chemistry class, but it means something a little different. But we're not trying to trick people, and if we look at it, a lot of these words do make a lot of sense. So we do need to be able to identify what are the reactants and what are the products. Well, the products are the things that are produced. That's what you end up with. The reactants are the things that react. And so when we draw a chemical equation, just like we read left to right, the reactants go on the left, and we have an arrow pointing to what they become, and those are the products. And this is a description of a chemical change. It's a chemical reaction. So again, the difference between chemical and physical changes can really be seen at the molecular and the atomic level. And of course, we cannot actually see that with our eyes, but we can imagine what's going on and think about it. In a physical change, those individual particles do not change. If you have an element, the atoms remain the same. If you have a compound, the molecules remain the same. In a chemical change, you do have the particles changing. The element may become a compound because it reacts with something else. The compound could break apart into individual elements, but the particles are changing. So in a chemical change, we end up with a completely new kind of matter. And what's sometimes a little bit confusing is you can have a physical change and the matter can change in its appearance, and yet it's still the same stuff. And that usually happens with a state change. So you take ice cubes and you melt them. And it doesn't really look like it's the same stuff, right? The density changes and it's all liquidy and runs all over the place where the ice cube just sat there nicely. You know, it looks different, but that's a physical change. So let's look at a little butane lighter, a little cigarette lighter. So what's in there is butane, and it's a liquid because it's under pressure. When you flick your Bic without actually lighting it, the butane will come out. It will vaporize and come out. Do these particles look the same as the ones in here? They do. All it's doing is it's evaporating and it's floating away. It's not changed in terms of what the particles are. This is a physical change. It went from a liquid state to a gas state, a physical change. The particles are the same. Now, if we ignite that and the butane burns, as the butane evaporates and comes out here, it's going to combine with oxygen in the air and burn, and this is a chemical change because now these butane molecules are being converted into water and carbon dioxide molecules. The particles are not the same anymore. We have made a new substance. Does that make sense? I don't want to, hammer it over and over again, but it's important to understand the differences between these things. So determine whether each change is physical or chemical. The rusting of iron, physical or chemical? That's a chemical change. We actually had an illustration of that. The evaporation of fingernail polish remover, which is acetone, from the skin. Physical. Okay, so how do you know that? Well, anytime you see a state change name, evaporation, boiling, freezing, melting, it's going to be a physical change. The burning of coal, chemical. Burning, exploding, rusting, combining with, changing into, those sorts of words are chemical. The fading of a carpet upon repeated exposure to sunlight. That's a chemical change. A lot of physical changes are fairly easily reversible, and chemical changes generally are not. That's not a hard and fast way of determining whether it's chemical or physical. Any questions? Mixtures can be separated based on their physical properties, and we can separate them by physical changes. So we're just going to briefly talk about some of those methods. Distillation. Probably heard of distillation. So here we have a solution, a mixture of different liquids. And when we heat this up and cause it to boil, the liquids in here have different boiling points. They boil at different temperatures. And so the one with the lower boiling point is going to boil first and go into the gas state, and then we don't just let it escape. We're going to collect it and run it through this condenser, which is this fancy glass tube, and it's got cold water running through the outside of it. So you take this hot gas, you run it through this cold tube and cool it down, and it condenses and dribbles down here, and you can separate the liquid that's more volatile, meaning it evaporates more easily, it's got a lower boiling point. You can separate that from the rest of this. And when they distill spirits, when they distill alcohol, this is what they do. So you take, barley or whatever you're making alcohol out of, and you get this mixture, and it's got alcohol in it from the fermented sugar, but maybe you want the alcohol out. You want it more pure, and you don't want grape skins or whatever floating around in there. Well, they boil it, and the alcohol is more volatile and will evaporate or boil off first, and so you can collect the alcohol. And back during Prohibition, I don't know if you studied that in history, and that was before my time, they used to have stills out in the woods, and they would make alcohol because, you know, it was banned. Well, they'd make still. They had a still. Well, a still is for distilling spirits. And so, you know, it's not hard to make alcohol. You just get some organic stuff, you know, grape juice or berries or dandelions or anything, almost wheat, and you get the bacteria in there and it will ferment. I was at Denny's once on a trip when I was a kid, and the peaches were fermented. That was a fun trip. But peaches will ferment. Anything with sugar in it will ferment. Then how do you separate it? Well, you distill it. And the guys would set these things up in the woods, and sometimes they didn't really know what they were doing, and so they would explode and cause problems. But distillation is a physical separation. We're not changing what the compounds are, we're just separating them. We're separating them based on differences in their physical properties. Filtration is another one. So you've got a mixture of a solid and a liquid, and you can pour it through a filter and separate. The filter, this is a lot like a coffee filter. You've got a funnel here with filter paper. And the filter paper has little holes that allow the liquid to go through, and they catch the coffee grounds. Or you make spaghetti, you boil spaghetti in water. How do you separate the spaghetti from the water? You use a colander. It's a funnel, a filter with big holes. The water goes through, the spaghetti stays behind. But the components are not changed in that process, they're just separated.